Okay, valve guides. Let's talk a little bit about valve guides. I got 6 heads to do. I did 2 of them already, so let's take a look at this one over here. If you look at the Harley manual, it tells you the clearance between the guide and the head is supposed to be about 2 thousandths of an inch. So how do you check that? Well, you need something like this, a telescoping gauge. Or something like this. They make these in a bigger size. This is the one I use for checking between the valve and the valve guide. So let's check out this one and see what we got for clearance. Okay, so let's check this one out. Stick your snap gauge in there. Excuse me, telescope gauge. Pull it out of there. Measure it. I like to use a stand to hold the mic. It makes it a lot easier. Let's see what we got. This one comes out to 563. Yep, 563. Alright, let's check the guide now, see what the guide comes out to. Okay, the guide looks like it's going to be just about 565. So this one's good to go. You know, you're able to press them out because you got a flat area here, so when you set up in a press, you can put a tube or something on here to, you know, hold the head in the right position. But on the back side, there's nothing flat to seat something to hold it in, so you end up driving them in with the hammer, which is fine. Got a couple pilots that I made, just a piece of scrap rod. And you know, they get to beat the hell after a while, so somewhere along the way I just replace them, just make another set, not a big deal. And if you've done a number of these, you could tell by the feel whether they're too tight or too loose. So this one feels pretty good going in. You could hear a change in the sound too once it gets all the way down. So let's check the that was the exhaust. Yeah, let's check the intake side next. And I got about 562. Eastern, not V-twin. Okay, so this one measures out to about 565. So it's about 3 thousandths too big for the hole in the head. You probably could force this in there, but we're going to take a little bit off of there. I'll show you how to do that in just a moment. And I order these things one oversized, 1,000th oversized, whenever I order the parts. And I do this because until you take it apart and measure them, you don't know what size you need. And I like to pre-order all this stuff so I got it ready to go. What I find is that over time, you know, the guides get knocked in and out a couple times. The holes get a little bigger. So sometimes you need an oversized guide, sometimes you don't. I order the oversizes because I could always make them a little bit smaller. So let's walk this one over to the drill press and I'll show you a quick, easy way to take 1,000ths of an inch off. And here's all there is to it. Let's check it. Okay, let's check it. That took off about a half a thou. Got another half a thou to go. Alright, so let's check it again. Alright, just about perfect. So that'll go into the head with a nice 2/1000 interference fit. Okay, so this is just like shampoo. Lather, rinse, repeat. The intake one you got to be a little more careful with. It doesn't have that tapered lean in. So you got to be a little more diligent when getting it started. Anyway, that's valve guides. Not a hell of a lot to it. Oh, one more step. As long as I'm here, let's ream them. The typical Harley intake, Sportster intake is, let's see, what is it? It's just a scotch over 5/16, so that is that is 0.311. So I have a 0.311 reamer. That's where I start at. If the valve stem is fat, I've got one more oversized reamer that I could stick in there. So ream it. And no, you can't use a drill bit. Drill bits don't make round holes. Okay, in the exhaust valve, the nominal size of the exhaust valve stem is 11/32. Yeah, and that would mean a decimal size of 0.341. Same deal. This is the 0.341. I'll measure the valve. If I need to go bigger, I've got a one size bigger reamer I could stick in there. And just FYI, you could buy guides that are supposedly already sized. Every one of those I've ever tried to use is too big. The hole is too big. So I would advise against that. You get a better fit if you ream them yourself to the size they need to be. You can see, I don't know if the camera will pick it up, but here's the cast iron that came out of there. So it does remove a fair bit of material, which is a good thing. You want the guide to start out too small so you could cut it to the right size. Anyway, that's it. Installing the reaming guides. Not a big deal. We're going to set this head up in the milling machine in order to cut a pocket for a new exhaust valve seat. One of the first things you have to check is the top of the newly installed valve guides. These corners might stick out past the mating surface of the rocker box. So when I flip this thing over to put it in the fixture, it's got to be completely flat. If these edges are sticking up, the head is going to want to rock a little bit on those valve guides. Obviously that's unacceptable. Head's got to be completely flat and firmly bolted down. Let's get in close over here and I'll tell you what we're trying to fix. I'll show you what we're trying to fix. Okay, this is the problem. This is one of the heads where you could see light coming in from behind the port. The exhaust valve is seating way down here below this lip. So this exhaust valve is probably 3/16 of an inch below where it started out at when it was factory new. And of course, if you keep cutting the seat down in there, the valve spring is going to lose tension. And in fact, when I took this spring out and put a little pressure on it with the spring compressor, it felt unusually loose. It felt almost so loose that I thought I could get it out with just my bare fingers, my bare hands. So you need to keep the valve height within a certain range, and we'll get into that later on when I set up the seats. You need to keep the valve stem at a certain height above the guide in order to make sure your spring pressure is correct. I wouldn't be surprised, and like I said, this is the one you could see light coming through and around here. I wouldn't be surprised if the owner told me that he tried to adjust the valves and the adjusting screws on the tappet blocks were screwed all the way in and he still had a little pressure on the valve. This thing is really, really deep. So what we're going to do is we're going to cut all this metal out of here, put a hardened seat in there, and I'm going to show you how I do that. Alright, so here's the setup. We have an adjustable angle plate bolted to the cross slide on my lathe milling machine over here. We're going to set up a cutter and we're going to bore down in here and create a new valve seat pocket. So let's get this on here. Come on, you bastard. There it goes. Oh, missed one still. Okay, there we go. Let's put some screws in there. If I don't lose them. Excuse me, let's put some nuts on there. Ay, ay, ay. Okay, let's put some nuts on there and just make them barely tight so we got room to wiggle this thing. Okay, just FYI, these videos, well, most of my videos, at least this video, was not intended to be a how do you do it. There's kind of a fair investment in tooling and stuff like that. If you've bought the tooling, the chances are you know how to use it. If you haven't bought the tooling, and you don't intend on doing this, there's really no point in me going into all the excruciating minutiae of how you go about setting everything up and doing it. But I'll give you the quickie overview. I've been doing these for a while, and I've tried 2 or 3 different ways to set these things up before I finally settled on this way, which I find works best for me. So what we're going to do is this. We're going to extend the quill, the spindle. We're going to lock it down. We're going to zero a digital angle indicator out on this thing. That's 0. I have here a little bit of a fixture, square piece of stock, precision 3/8 hole because my pilot is 3/8, 0.375, and we're going to zero this thing in the, I guess, XY dimension, and it is 0.40 right now. So I got to loosen the adjustment screws for the angle plate. It's a little hard to get back in there and keep the camera in a position where you could kind of see what's going on. So we're going to set that to 0. And that's 0, pretty much right there. It's a little off. I'm going to tighten it up. Okay, there we go. It's kind of drawn it down to the right spot. Okay, very good. The 0 hasn't moved. Perfect. Okay. Okay, those are tight. Okay, those are tight and I'm still at 0. Now we're going to take this thing, we're going to turn it 90 degrees. We're going to re-zero the digital indicator. Let me back out here a little bit. Okay, we've already zeroed this angle, so now we're going to zero the other angle. So I've got the digital angle indicator connected to my quill, and we're going to transfer that over here, and we're going to re-zero this thing again. Now these whole screws, nuts here, are a little bit on the loose side, and that's going to let me twist this thing. Okay, that's making it worse. Okay, that's too far. Bringing it back. Okay, 0. So we're going to tighten these down. We're going to tighten these down as evenly as I can and try to make sure we don't lose the 0. So far, so good. Perfect. Oops, moved a little bit all of a sudden. I knew that was going too easy. Try it again. It's pretty tight. Pretty tight. Pretty tight. Okay, perfect. So we've got it. We've got the valve. This is an arbor, a pilot for my valve seat cutting tool. So it serves double purpose. It serves as the pilot for the seat cutter and the pilot for the valve seat cutters. So this thing is now parallel vertically in both axes with the spindle of the milling machine. So the next thing we got to do is get it to line up with the center of the mill. So I'm going to show you how to do that just right now. Let me get this stuff out of the way. Don't need this anymore on there. Now right now we're just kind of roughing it in, getting it in the ballpark. Let me get the cutter out of the way. Okay, the camera cut off on me somewhere along the way. I'm not sure where, so let me just kind of recap where we're at. The pilot was roughly lined up with the spindle and the quill and the driver for the seat cutting tool. The mill was manipulated left to right, forward and back to center this under the driver. The driver slides over it easily. I put a couple of drops of oil on there. Locked the quill and the spindle down. Turn the mill on. Loosen the hold down bolts so that I could, wiggle and jiggle and let this thing find its center under the quill and the spindle. And the professional machines have an airflow table that does essentially the same thing. But anyway, I'm happy with this alignment. I tighten the bolts down. Let's get the quill and the spindle out of the way. Shut everything down, and we're ready to start cutting. So let's start cutting. Got to put the cutter back on. Got to find the Allen wrenches. There they are. Okay, we're ready to cut. Let's see what happens. Alright, let's see where we're at. Alright, looking good. Okay, I've got you in about as close as I could get you to watch the rest of the operation. So far so good, nice smooth cuts, working out pretty well. The critical dimension here is gets to be about how deeply you sink the pocket and the head. And it's a very difficult area to measure off of because everything is curved. There's no real flat surfaces. So what I've done is I've made a dummy, no, that's not me, it's this part here. I've made a dummy seat, and it's a little smaller than the seat that goes in there, and I use that to just kind of test fit my depth on here. So what I'm aiming for is about 20 thousandths below flush. So let's cut some more and get it done. Let's check our progress. You could always take more off, but you can't put any back. Okay, probably got another 50 or 60 thou to go. Getting real close. Ooh, very close. I'm going to try to go about another, 10, 15 thou. We're just about flush. I'm going to go a little more than that. Go a little bit more. I'm going to call that good. I'm just a little below the surface of the head. You know, I could, I don't have to, well, if I cut this too deep, of course, I'm not going to gain the advantage I sought to gain, which is, you know, getting the valve stem height to be correct. If I cut it too low, the stem is going to, you know, this valve is going to sink too deeply in there, and I will have gained nothing. If I don't cut it deep enough, the only trouble with that is it's going to cause me to have to move a lot more material off the seat with the seat cutter, and that's kind of a pain in the ass. So I don't want to make myself do more work by not cutting it deeply enough, and I don't want to ruin the head by cutting it too deeply. So you've got a kind of a range in there to play with. But I'm just, I don't know, maybe 20 thou below the surface of the head. That should leave me probably 30 or 40 thou material to remove from the actual seat that goes in there. This part of this operation is done. Next part coming up.